Okay, we're looking at page 14 here. This one combines vertical and horizontal shifts. So in the first exercise, we have the parent function, f of x is equal to the absolute value of x. It's saying g of x is f of x minus 6. So I'm going to write, g of x, f of x minus 6, and then replace the f of x with what we know it really is. And that's the absolute value of x. So it's going to be the absolute value of x minus 6. Graphically, we're just going to slide down every point 6 units. Grab a couple more points along the way. We'll take this one here, 1, 2, 3, 4, 5, 6. And then just line segment it up. Throw an arrow on at the end. Same deal over here. And that would be my g of x. Now h of x is saying to shift it to the right. I'm sorry, to the left 3 units. So f of x is the absolute value of x. F of x plus 3, we get that by replacing the x in my parent function with an x plus 3. So it becomes the absolute value of x plus 3. And since h of x and f of x plus 3 are the same thing, I could replace this with an h of x. And that's going to be x plus 3. So I'm taking my original function and shifting it 3 units to the left. All right. So I'm going to take my original f and move it 3 units to the left. So I'll put this point here, here, here. Just grab any convenient point, 1, 2, 3. 1, 2, 3. And once you have enough to get you through any axis that might be relevant, x-axis, y-axis, then we can draw line segments, throw some arrows on it, and label it up, in this case, h of x. All right, so again, this one was 6 units down. This is 3 units left. Now, exercise 2 is kind of a combo. All right, so we have our parent function. They're telling us that not only are we doing a shift in the horizontal direction, but we're doing a shift in the vertical direction. All right, so g of x, they're telling us, is f of x plus 3 minus 6. We know f of x is equal to the absolute value of x. So same idea as before. I'm going to take every instance of x and replace it with an x plus 3. So that's going to get me an absolute value of x plus 3. And we have that minus 6 coming along for the ride. So that's my g of x. But if we know that this means shift left 3 and down 6, then we can get to our final answer all in one shot instead of doing it left 3, draw a graph, down 6, draw another graph. Do it all in one shot and take every point and shift that point left 3 units and down 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Grab another one here. I'll take this guy over here. So 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. I'm just grabbing any point that I think looks kind of clean. Like, for example, I could take this point if I want and go left 1, 2, 3, and then down 1, 2, 3, 4, 5, 6. Do that. Whatever makes sense. You could also, since we know the slope isn't going to change, we can rely on it still having the same slope of 1 as you go to the right and the same slope of -1 as you go to the left, and populate all those points in that way. All right. And if you have the function, you could always pop it into your calculator and get a table of values. All right, so let me take these things out. What do we call it? G. So g of x equals absolute x plus 3, then minus 6. Grab some clean points here, and you could plot those, but you could also hit that little gear and create a table of values, and just keep going until you have enough points. Right here, and maybe you want a few more, but you can always just kind of introduce them. It doesn't matter what order you put them in. If I want to know what's going on at -3, I can put it there. I can put -4 there. It doesn't make a difference. All right. I could change values that are in there. I can go as needed. This one that's undefined is because I don't have an x value there. So if I put like 5 or something, I can get another point. All right, so you could do it in really whatever order makes the most sense. Now it says, what are the zeros of the function? Zeros are where they cross the x-axis. It looks like that's happening right here and here, -9 and +3. All right. Next up, we have a radical function. All right, so looks like we have our parent function here. It looks like the square root of x. I don't think they tell us, but we can kind of verify it, because at 4, we have a y value of 2. At 1, we have a y value of 1. The square root of 1 is 1. The square root of 4 is 2. At 9, we have a y value of 3. Right? So just having an idea what the parent function looks like can really get you going. What is the formula for the function f of x? And that's really just f of x equals the square root of x. Knowing the shape is the first step. All right, so we're going to say f of x is equal to the square root of x. That's our parent function. The function could be defined by x plus h, f of x plus h plus k, where h and k are unknown constants. What are the value of h and k? All right, well, this one, so again, we're talking about g of x here. We shifted over 3 and up 6. All right, so my horizontal movement is going to be a total of 3 units. All right, and we can go back to our general definition, a rightward shift if the k value is negative. All right, so we're going to put in an h value of -3, all right, because we went right, but we'll put it in as a negative, and then up 6, so my k value would be 6, and so g of x is going to be f of x minus 3 plus 6. All right, now they say write a formula. It's kind of what we're working towards. This is telling me if I know my f of x is equal to the square root of x, if I want f of x, minus 3, I'm replacing the x with an x minus 3. So my g of x is going to be the square root of x minus 3 plus 6. And we could take a look at that. All right, one good thing about Desmos is it understands function notation. All right, so I put in this rule here, and Desmos will understand that. Now I can verify that that's actually the same as saying the square root of x minus 3 plus 6, right? They map to the same location. So turn one on, turn the other on, they're going to the same spot. Now I just put this in as an expression. I'll just do it as y equals as a placeholder, just so it's in the proper equation form. But yeah, that, you know, there's a bunch of different ways to get it in the calculator, which is kind of nice. Use your calculator to verify the formula you wrote in C is the correct one. I guess I just did that. For number 4, we have a graph of f of x. They're saying g of x is a shift. So g of x is a shift. All right, that shift is going to be, again, just like over here, if it's a negative inside the parentheses, we're talking about a movement to the right. So shift right 5 and down 3. All right, so every point, I'm going to take it and shift 1, 2, 3, 4, 5, down 1, 2, 3, down 1, 2, 3, 1, 2, 3, 4, 5, down 3, and plot a point. Then connect, and we have our graph. So that's g of x. All right, so for the domain, we're talking about all possible values of x. So for my first function, f of x, that goes from -7 to +3. For my g, goes from -2 to +8. All right, and that represents a shift of 5 units to the right. Now for my range, the lowest value on my f graph is -4. The highest is 8. And for my g, the lowest one is -7, and the highest one is 5. Also representing a shift, this time down 3 units. And they say give all the solutions. Solutions would be where they intersect. Looks like it only happens at this one location along the domain. So that would be at 0, 2. And actually, just to kind of put it the way they would want it, the solutions they're looking for would be the x values. So actually I could leave that. 0, 2 is the point of intersection. So the solution would be when x is equal to 0. That's when they cross.